So you're walking down the street, you look up, and you see this massive, incredible skyscraper, right? You probably think, wow, an architect designed that, and you'd be right. But that's only like 1/10 of the story. It's like saying a movie was only made by the director. What about the stunt doubles, the special effects artists, the composers? That building is standing, it's comfortable, it's safe, and it's lit up at night because of a whole team of unsung heroes, the architectural engineers. They are the wizards behind the curtain, the secret sauce, the ones who figure out how to make the architect's beautiful drawing actually work in the real world without falling over, catching on fire, or feeling like a sauna in July. Today, we're going on a deep dive into this hidden world. We're going to pull back that curtain and see the engineering magic that brings our buildings to life. Think of it like this. If a building is a human body, the architect designs the face and the hairstyle, but the architectural engineers design the skeleton, the circulatory system, the nervous system, and even the immune system. It's a complex, fascinating symphony of different disciplines all working together. We're going to break down exactly what these engineers do, from making sure the building can withstand an earthquake to ensuring you have Wi-Fi and the perfect lighting to read a book. By the end of this video, you'll never look at a building the same way again. Seriously, you'll walk past a simple office building or your own apartment complex and see it not just as a structure, but as a masterpiece of problem solving. You'll start to notice the little things, the placement of vents, the design of the windows, the hum of the systems, and you'll appreciate the incredible amount of brain power that went into every single square foot. So, grab your hard hat because we're about to explore the world of architectural engineering. Alright, first up, let's talk about the rock stars who keep these buildings from turning into a pile of rubble. The structural engineers. Their job is, in a nutshell, to fight gravity and win, every single day. When an architect hands them a beautiful, ambitious design, the structural engineer has to figure out how to make it stand up. They design the building's skeleton, the beams, the columns, the foundations, the entire framework that holds everything together. They have to think about everything, the weight of the building itself, the weight of all the people and furniture inside, and even the forces of nature, like wind, snow, and yes, even earthquakes. It's a high-stakes game of physics and material science. They use incredibly complex software to model and simulate how a structure will behave under stress. They ask questions like, what happens if a hurricane with 150-mile-per-hour winds hits this tower? Or, how will this concrete foundation settle over the next 50 years? They choose the right materials, whether it's steel for its strength and flexibility, or reinforced concrete for its compressive power. Every single connection, every bolt, every weld is meticulously planned and calculated. They are the reason you can stand on the 102nd floor of a skyscraper and not feel it swaying like a tree in the wind. They are the true foundation of every great building. So, the building is standing, which is great, but now we have to make it livable. You don't want to work in an office that's freezing in the winter and sweltering in the summer. That's where the mechanical engineers come in. They are the masters of the internal environment, designing the building's circulatory and respiratory systems. This means they are in charge of the HVAC. That's heating, ventilation, and air conditioning. They figure out how to move massive amounts of air around the building efficiently and quietly to keep every room at the perfect temperature. It's a giant puzzle of ducts, fans, boilers, and chillers, all strategically placed. But their job doesn't stop at just keeping you comfortable. They also design the plumbing systems. Every tap, every toilet, every drain pipe, that's them. They make sure you have clean water coming in and wastewater going out, which is a way bigger deal than it sounds, especially in a 50-story building. And crucially, they are also involved in fire protection. They design the sprinkler systems, ensuring that in an emergency, water can get where it needs to go to keep people safe. They are the invisible force that makes a building not just a structure, but a comfortable and safe place to be. Okay, our building is standing and it's comfortable, but it's also completely dark and you can't charge your phone. Enter the electrical engineers. the people who design the building's entire nervous system. Their job is to bring the building to life with power. They map out the entire electrical grid for the structure, from where the main power line enters the building to the location of every single outlet, light switch, and light fixture. They have to calculate the total power demand of the building, thinking about all the computers, lights, elevators, and HVAC systems, and design a system that can handle that load safely without overloading. This is a massive responsibility. A mistake here could lead to power outages, or far worse, an electrical fire. So they design complex systems of transformers, circuit breakers, and wiring to distribute power safely and efficiently. But in the modern world, their job has expanded way beyond just lights and plugs. They also design the building's communication infrastructure, the wiring for internet, phone lines, and Wi-Fi networks. They're also responsible for life safety systems like fire alarms, emergency lighting, and security systems. So, next time you flip a switch, plug in your laptop, or connect to the Wi-Fi, thank an electrical engineer. Okay, so now let's talk about the building's skin, its face to the world. This is actually the domain of a super specialized group called facade engineers. You might think the look of the building's exterior is just up to the architect, but really, the facade engineer is the one who makes that vision a reality. They are kind of like the bridge between the architect's aesthetic dream and the structural engineer's physical laws. They design the building's outer envelope, the glass, the metal panels, the stone, whatever it's made of, to do so much more than just look good. The facade is actually a high-performance system that has to do a bunch of things at once. First, it has to keep the weather out. Rain, wind, snow, the facade is the first line of defense. Second, it has to be structurally sound and safely attached to the main frame of the building, which is a huge challenge when you're hanging giant panes of glass hundreds of feet in the air. Third, and this is a big one, it plays a massive role in the building's energy efficiency. The facade engineer selects specific types of glass and insulation to control how much heat gets in or out, which can drastically reduce the energy needed for heating and cooling. It's honestly a blend of material science, structural engineering, and environmental design. Ever been in a restaurant so loud you can't hear the person across the table? Or a library so quiet you can hear a pin drop? That's not an accident. That's the work of an acoustical engineer. Inside a building, they are the masters of sound. Their job is to manage noise and vibrations to create the right auditory environment for a space's intended purpose. In a concert hall, they want to shape the room so that music sounds rich and clear from every single seat. They use complex computer models to predict how sound waves will travel and reflect off different surfaces. But they also work to eliminate unwanted noise. In an apartment building, they design walls and floors that stop you from hearing your neighbor's TV. They isolate the vibrations from the building's mechanical equipment, like the HVAC system, so you don't have to listen to a constant annoying hum all day. In an office, they use materials like acoustic panels and ceiling tiles to absorb sound and reduce echo, making it a more productive and less distracting place to work. It's a subtle science, but it has a huge impact on our comfort and well-being inside a building. This next one is one of the most important, and it's all about keeping people safe in the worst-case scenario. Fire protection engineers, or FPEs, are specialists who dedicate their careers to protecting buildings and the people inside them from fire. While the mechanical engineer might design the sprinkler system, the FPE looks at the entire building holistically. They use the science of how fire starts, how it grows, and how smoke travels to design a comprehensive safety strategy. This is way more than just putting a few fire extinguishers on the wall. They start by helping design buildings to be inherently safer. This means planning escape routes, determining the right fire-resistant materials for walls and doors, and designing smoke control systems that use fans to keep escape paths clear of deadly smoke. Then they design the active systems. This includes advanced fire detection systems that can sense a fire in its earliest stages, alarm systems that effectively alert everyone inside, and suppression systems like sprinklers or, in special cases like data centers, clean agent gas systems that put out fires without using water. Their work is a quiet, constant presence that we all hope we never need, but are incredibly thankful for when we do. Finally, let's talk about the discipline that's shaping the future of all building sustainability. In the past, we built things without thinking much about their impact on the planet. Today, that's completely changed. Sustainability and environmental engineers are focused on one big goal: minimizing the environmental footprint of a building throughout its entire life, from construction to demolition. They are the eco-conscience of the design team, constantly pushing for smarter, greener solutions. This involves a whole range of strategies that touch on every other discipline we've talked about. They champion the use of sustainable and recycled materials, like reclaimed wood or concrete made with industrial byproducts. They work with the mechanical and facade engineers to design hyper-efficient systems that use as little energy as possible, incorporating things like geothermal heating, solar panels, and green roofs that help insulate the building and manage stormwater. They also focus on water conservation, designing systems for rainwater harvesting and water recycling. Their ultimate goal is to create buildings that are not just safe and comfortable, but are also healthy for the people inside them and for the planet as a whole. So there you have it. The next time you walk into any building, I want you to just stop for a second. Look at the sprinkler head on the ceiling, feel the cool air from the vent, notice how the lights are perfectly bright but not glaring, and appreciate that you can't hear the rumbling of the subway from 50 feet below. None of that is an accident. It's the result of thousands of hours of work by brilliant and dedicated teams of architectural engineers. They are the silent collaborators, the invisible geniuses who take a beautiful idea and make it a functional, safe, and comfortable reality for all of us. It's this beautiful intersection of creativity and hard science. You have to be super creative to solve these complex, three-dimensional puzzles, but your solutions have to be backed up by math and physics, because if you're wrong, the consequences are very, very real. It's this high-stakes problem-solving that makes this field so cool. These engineers are literally building the world we live in, one calculated beam, one efficient air duct, and one life-saving fire alarm at a time. They are the proof that engineering is one of the most creative and impactful professions on the planet, and that's what's so amazing. We spend 90% of our lives inside buildings, yet we rarely think about the complex web of systems that make them work. So the challenge for you is to start noticing, see your world through the eyes of an engineer. And if this sparked something in you, maybe this is a world you want to be a part of. Because we're always going to need buildings. And that means we're always going to need the hidden superheroes who know how to make them stand tall, keep us comfortable, and protect our planet. Thanks for watching.